Welcome to Share Science. Over the last few weeks, we've been nerding out on the power of magnets. If you haven't already seen them, you should go back and watch the first video in the series, which we've linked in the top corner. Today, we're kicking it up a notch by probing the power of magnets to read your mind. What do you think? Sounds crazy, right? But it's real, and it's happening now through the combination of magnetic resonance imaging, or MRI, and artificial intelligence. Let's dive in. Before we can get to the telepathic nature of MRI, we have to cover a few key terms to understand the process. First, we have to review the natural rotations atoms make, known as precession and resonance, which both play a role in the MRI process. Next, we'll talk about the characteristic relaxation times of these processes that dictate the speed that MRI can take images. Finally, we'll examine the blood oxygen level dependent or bold effect that relies on the resonance of deoxyhemoglobin, which can be used as a substitute for brain activity and is the signal researchers use in functional MRI to read minds. Let's see how it works. MRI generates images of the body by measuring the response of the hydrogen found in water in the body to applied magnetic fields. Each of these hydrogen atoms or protons spins on its own axis like a tiny magnet that will respond to external magnetic fields. This natural spinning process is known as precession and has its own natural frequency that we can leverage with pulsed magnetic fields to take images of the body. In order to minimize the effect of these precessions, a static magnetic field is applied to pull the spins in the same direction. Then, by applying an additional pulsed RFE field, we can cause the protons to resonate, which absorbs the applied energy which can be measured. By scanning the pulsed field, the system generates an image of tissues in the body. Now, different tissues respond differently to these applied fields with varying relaxation times, which can be used to answer different questions about the body. This time series provides an idea of how the process works. By changing the angle of the applied pulse and measuring the response or echo of these different signal types, known as T1 and T2 signals, doctors can better assess the different underlying issues that might be causing a patient's illness. Okay, so imaging the body is one thing, but how is it we can read the mind with MRI? Since MRI is based on resonance relaxation times, we can use the blood oxygen level dependent effect to measure brain activity in real time by using the characteristic relaxation times of deoxyhemoglobin as a measure of activity in different parts of the brain in a technique known as functional MRI. By focusing on the regions of the brain responsible for image processing and coupling the results with a form of artificial intelligence known as deep neural networking, researchers were able to assess the brain scans produced when participants were shown the images on the left to produce the images on the right. While not a perfect reproduction, this research is still developing, and researchers have more recently been able to decode entire thoughts and sentences using 3 parts of the brain used for language processing. Scientists believe this kind of technology can play a critical role understanding patients who have lost their ability to communicate, and these results are really promising. To summarize, we covered the amazing way scientists use magnets to look inside your body. The technique depends on the response of protons in your body to magnetic fields through precession and resonance processes. Different tissues in the body have different relaxation times when excited with an RF pulse, which allows doctors to understand more about what's happening in the body. What's more, by focusing on the resonant response of deoxyhemoglobin in a technique known as functional MRI, we can image brain activity in real time through the blood oxygen level dependent effect. Through this technique, researchers can actually decode the thoughts of the person being scanned, which represents an amazing opportunity to expand the way we communicate and understand human thought. We hope you liked today's video. If you haven't already seen them, you should go back and watch our previous installments of this series that covered where magnetism comes from and how it's used in the design of electric motors. If you liked this video, hit subscribe below and you can get new content every week in your feed automatically.